So welcome to section. Today I am going to explain the construction part of the glass electrode, which I explained the last class in the certain points I explained. So now I am going to explain construction of a glass electrode. Glass electrode consists of three parts. It is an actual glass electrode. It is the upper part have a U type of tube like structure, and the bottom one you have a glass bulb, which is a special type of membrane you have. The glass bulb, which is consists of the membrane, which is very low melting point in nature but shows very high conductivity, and this makes the membrane to find the H plus ion present in the solution. And for electrical contact we have a platinum wire which is coated with silver chloride, is electrically coated with silver and silver chloride coating on the platinum wire. And third one is 0.1 mole of HCl. This construction part, this tube structure, it is filled with 0.1 mole of HCl solution. So this is the structure of a glass electrode, and this is used for the estimating pH of an unknown solution. So the construction part is over. Now we have to write the cell representation. First, for any cell representation, first we have to write the metal contact. For electrical contact, here we are using platinum. So first I am writing the platinum, then the HCl, so which is the electrolyte present in the glass electrode. The concentration of glass electrode is 0.1 molar, so I mentioned within the bracket. Now I am writing the another part is glass membrane. Why we are taking glass membrane in the representation means this membrane is only take part in the reaction, so that's why we are taking a glass membrane. So this is the construction part of the glass electrode. Now we are going to write the Nernst equation for this glass electrode. Eg equal to E naught G plus 0.0591 log of H plus ion. Here we are writing only the reactant and product part. So the product only we are taking, that is H plus ion. This is already we know that this is the Nernst equation, and this is a not represent the standard one, and E represent the potential, that is potential of the glass electrode is nothing but potential standard electrode potential of the glass plus 0.059. This is short form nRT plus RT by N. So the substituting the gas substituting the constant values, we have a 0.0591 and log of H plus ion. This is the final form of the Nernst equation for the glass electrode. And now we have to conclude how we can use this equation for the determination of a pH. Now we know that pH is nothing but a minus logarithmic of H plus ion concentration. So we know that this pH is can represent minus log of H plus. So we have to substitute this thing, that is log of H plus and plus we are taking, so minus log of minus 0.0591 pH. So you are substituting minus log H plus, instead that we are substituting pH. So how you are getting the negative sign? Here the plus is nothing but minus into minus. So one minus you are taking minus log, so the other minus is here. So the glass electrode Nernst equation is standard glass electrode potential minus 0.0591 pH. So how we can use this glass electrode for the determination of a sample solution? First we are going to see the construction of the cell. So for any glass determination of a potential, we need both electrodes, anode and cathode. So here the glass electrode is placed in a beaker which contains the sample solution which is to be measured, and it is combined with the calomel electrode. We already seen the construction of the calomel electrode. It is metal insoluble type of glass, metal insoluble salt type electrode. So here we are glass electrode is coupled with calomel electrode. This is the construction part of the cell. Now we have to write the cell representation. As usual, the anode is written in the left hand part and cathode is written in the right hand part. So whatever we write in the cell representation of the glass, that is represented here. First platinum and HCl, which is the electrolyte present in the medium, and concentration is 0.1 molar, and glass membrane, which is also take part in the electrode, and whatever the cell representation of a calomel electrode, now it is written in the cathodic part. KCl, this in the saturated form, it is used in the electrolyte, and here it is a metal insoluble salt. So mercury is here, and mercurous chloride is here, Hg2Cl2, which is in the solid nature. So that is present in the next one, and for electrical contact you are having a platinum wire. So this is the construction part of the overall cell, and now we have to use the Nernst equation, that is E cell. How we can estimate the potential of the cell equal to a potential of right hand side minus potential of left hand side. In all the cases, the right hand side we represent the cathode and left hand side anode. So in construction also we draw the structure like that only, that is your anode right in the left hand part and cathode in the right hand part. So that is why the equation represents the E cell equal to E right hand side minus E left hand side. So here we can write your right hand side is nothing but calomel electrode. So potential of the calomel electrode minus potential of the glass electrode. So now we are substituting whatever the known thing in the equation. We know that the E calomel is nothing but 0.2422, which we get a standard value that is measured by coupling the calomel electrode with the hydrogen electrode while you having a saturated KCl solution in the electrolyte medium. So this is the constant value. So E calomel is the value is 0.2422 minus E cell of the potential of the glass is nothing but E naught of the G minus 0.0591 pH, which we got in here. No, we substitute this Eg, whatever the thing here we are substituting here. Then 0.2422 minus, the minus is going inside of your bracket. So minus E naught of G, minus into minus plus 0.0591 pH. So E cell is nothing but the 0.2422 minus E naught of G plus 0.0591 pH. So now we need to find the pH only. So we keep pH in one side and all other thing in the another side. So E cell, which is already in the left hand part, and this 0.2422 which is in the right hand part is moving on the left hand part, so it gets negative sign, and which is minus E naught G, no, that moving left hand part of your equal, so it gets positive charge E naught of G, which is equal to 0.0591 pH. So now I need to measure pH only. So pH equal to E cell, which is I am writing in the left hand part, no. So I just write in a vice versa type. The left hand part I am writing right hand side, and whatever here I am writing here. So pH only I need. So the content in the left hand side E cell minus 0.2422 plus E naught G divide by 0.0591, because it is in the multiplication, and while moving opposite of equation it becomes divide. So the pH of any solution can be estimated by using this equation. So in this way the glass electrode is a very advantage one to find the pH of a sample solution. So now we are going to study the advantages of the glass electrode over other electrode, because we studied hydrogen electrode, calomel electrode, silver chloride electrode. So many type of electrodes we studied. So in that, what is the specific application of the glass electrode? So the advantages is it is stable in any oxidizing and reducing reagent. So it is not affected by the oxidation and reduction reagent that present in the sample solution. And second one is it is stable in the metal ion and poisonous, even colored solution, which is very dark solution. That too can estimated That too, the H plus ion concentration can be estimated by glass electrode, and we need very small quantity only for the estimation. And while we are using the glass electrode, here the equilibrium is happening now, which I explained in the last my lecture. Here the exchange of the H plus ion with the membrane, that makes a potential difference. That potential difference is used to estimate the H plus ion that present in the sample solution. Here the membrane which separate the known concentration H plus ion solution and the sample solution. This makes a potential difference. This potential difference initiate the exchange of the H plus ion from membrane to solution. So that makes this potential of a membrane, because the bulb, which is a special type of a membrane which shows a high conductivity. So thereby the equilibrium, the exchange of the ion in glass electrode is attained immediately after placing in the glass electrode in the sample solution. And we find that it has a very important industrial application, because all our industrial application we need, or we have to maintain a pH of a medium. So for that we need measure or monitor continuously the pH of a medium. So that is the main application of glass electrode. What are all the limitations? The limitation, when you think about the glass electrode, the pH which is very high. For example, we know that pH scale is 0 to 14. So 0 to 7 is a neutral, the 7 is a neutral one, 0 to 7 is acidic, 7 exactly neutral, and 7 to 14 is a basic in nature. So if you are using the glass electrode in the higher pH, that is about 12 or 13, that pH which is in basic in nature, that may corrode the structure of your glass membrane. Because of that it may limited to measure the pH at very high pH level. And the second one of limitation is special potentiometer is needed, because we need to measure exact value of pH. So somewhat resistance is happen in the glass electrode, so we need a special type of potentiometer. See, potentiometer we are using, that potentiometer should be a very special and a very qualitative one type of glass electrode. So up to that we discussed what is the construction of the glass electrode, what is the nature of a glass bulb in that, and what are all the components of the glass electrode, and next how this glass electrode can used in the estimation of pH of a sample solution, and in that construction, cell representation, and how the Nernst equation is helpful to find the pH of a unknown solution, and what are all the advantages of a glass electrode, and what is the limitation of the glass electrode, that we discussed in today's lecture. Thank you.